Hello students, in this video we are going to discuss about the input buffering which will occur in lexical analysis phase. So compiler is divided into different phases. The first phase is lexical analysis. So here in this phase the input buffering will be occurred. So now we will see detail how what is input buffering, how it will be handled. So in the lexical analysis phase, that lexical analyzer, it will reads the input string from the disk. Disk means here it is a secondary disk. If you want to read character by character, one by one character from a secondary disk, it is a time-taking task. So to improve the performance of a lexical analyzer, it will use the compiler. The lexical analyzer uses the input buffering. So instead of reading from the secondary disk one by one character, it will read from the input buffer. So now we will see how it will look like, the input buffer. Input buffer is a storage device. It will be divided into cells like memory. In each cell will place one character, single character. It will scan from the left to right, one character at a time. So like in theory of computation, you know already about the Turing machine. The Turing machine also will read the character one by one from the left to right. So like that also, like that it will be the input buffer will work here. So here the input buffer will be having the two pointers, that is begin pointer and forward pointer. And initially it will place those two pointers will be placed the first character, okay, at the first character. So after that the forward pointer will move forward up to second character, third character, it will scan, okay. So here the size of the input buffer will be depending on the compiler, maybe 1024 characters or 4096 characters it will be having. So these will be the sizes, okay. So n characters means depending on the input buffer size, that means 1024 here, then it will read the 1024 characters at a time. Otherwise the input buffer size is 4096 means it will read all the characters at a time, that means 4096 characters at a time, okay. So that will be the size of about the input buffer. Now we will see how it will be moved, okay. So see here, this is the begin pointer and it is moving the next character, that is forward pointer is moving into the next character, okay. So here this is n, this is the next character is n. After that the forward pointer is moved to again here. So here after the int, the one blank space occurred. One blank space occurred means forward pointer while moving to the blank space, then it will tell the begin pointer also will come here. So as soon as it reached the blank space, it will identify it is a token. That means int is a token. So int means it is a keyword. So keyword in symbol table, it will place this key under the keyword session, it will place the int, okay. So after that a begin pointer will placed here. Next this forward pointer will move again, it will identify this I, then forward pointer will move again, it will identify the symbol, and like this it will scan the entire entire buffer, that is it will scan. While reaching the entire buffer, it will place, if it is a blank, so it will tell the entire lexeme will be scanned and it will be placed, okay. So I already told the buffer length will be depending on the compiler. It will be like n characters means entire 1024 characters or 4096 characters will be read into this buffer. So here the block of data first transferred into a buffer and then read by the lexical analyzer, okay. Instead of reading from the disk, it will read from the buffer. So radically it will obviously it will be improve the performance of a compiler. So here in this buffer there will be two schemes, one buffer scheme and the two buffer scheme. One buffer scheme means only one buffer will be used for reading. Two buffer means two buffers will be used. So here this is the one buffer, it will be, so like that here one buffer will be used to read the store the input string. So from the forward pointer and backward begin pointer it will use, and it will scan this entire the string using one buffer. Then what will be the disadvantage of this one buffer scheme? If lexeme is very strong, very long, then it crosses the length of the buffer boundary. So again, to scan the rest of the lexeme, that means half lexeme already scanned. If you want to scan the rest of the lexeme, the buffer has to be refilled. Okay, obviously there is no choice, only one buffer only we do have. So if we want to refill that lexeme, that makes overwriting of the first lexeme. So half lexeme will be placed first. So obviously the length of the lexeme is very long. The other half will be, again it will be overwrite and it will replace. So this will be a disadvantage. The entire lexeme will not be read at a time. It will be read by overwriting. Maybe sometimes it will be missing and all. It will happen. So this will be the disadvantage of the one buffer scheme. So here, to overcome this one buffer scheme disadvantage, two buffer scheme has been occurred here. That means two buffer means here instead of using the one buffer, in this method two buffers are used. So buffers will be same length. Suppose the input buffer length is 1024, means two buffers also, two buffers will be maintained the same length. That's not the thing if one buffer is 1024 characters and the next buffer is 4096 characters. Okay, so here it needs to maintain the same length of the two buffers. Okay, so the first buffer and second buffer are scanned alternatively in this two buffer scheme. See here, this is the two buffer scheme. Here the sentinel characters will be used to identify the first buffer and it is ended, the first buffer ended. Here also it is used, the second buffer is ended. So the input same like input begin pointer and forward pointer will be used. So here it will be identified, okay, here the first buffer has been ended, the first buffer. So as soon as the end of file it will be reached, the begin pointer also will be reached here. From this it will scan the second buffer first character from here. Okay, so after this, as soon as reaching the second buffer end of file, so it will go to the first buffer again. So here we already read the first buffer. So again it will read the next input of the from the input next input of the lexeme that will be placed in the first buffer. Okay, alternatively it will read the first buffer and then second buffer. After completion of the second buffer, then it will read the first buffer. Okay, here it is EOF is called a sentinel character, is a special character, and the sentinel is it is not a part of a program. It will be used as a for identifying the first buffer is ended and second buffer is ended. Okay, so here input buffer is nothing but to improve the performance of a compiler. So if any input is reading from the secondary disk, lexical analyzer will read one by one character. If one character is reading from the disk, again second character is reading from the disk. So it is a time taking process. It will drastically reduce the performance of a compiler. So that's why if you want to improve the performance, the entire characters will be first read into moved into the input buffer. From the input buffer it will scan one by one. So here from instead of using reading from the disk, it will read from the input buffer. It will improve the performance. For that it will be using. Hope you understand this video. So this is the first unit, ending of the first unit. Then we will move into the parsers. What is the use of in next video? Parsers and the different parsers we will read. Okay. Hope you understand this. Thank you.